So here's an experiment designed to show the position that an object appears in its image in the mirror. So when you look into a mirror, you see things as though they're inside the mirror, and that's as a result of the light obeying the law of reflection when it strikes the mirror. So in order to test this, we're going to use this little, there it is, small flat mirror called a plane mirror, because it's flat, completely flat. I'm going to pop it down on a piece of paper, which I've put on top of some polystyrene, which is you can stick pins into quite easily. Draw around the mirror, like so, on this piece of paper here.
I don't know that one.
Hush, Alexa. There we are. Draw around the mirror. And then we need to have an object that we're going to look at in the mirror. And I'm going to choose this pin here. See that? It's got a little head on it there. I'm just going to put it a certain distance in front of the mirror over here. So light bounces off this pin here, which is the object pin. I could even write next to it object, just to be clear. And it's going to bounce off the mirror and then head in that direction. So if we get our eyes, or in this case the camera, and look down in a position where my finger is now, we'll see that object in the mirror. So I hope you can see, there it is. We can see the reflection of that pin in the mirror appearing to be somewhere inside the mirror. We need to work out exactly what's going on there, where the beams of light are travelling. So we need to use further pins in order to work this out. If the light's bouncing off the mirror, which it is, hits this pin, which is over here, that's the object pin, it's not quite in focus there, and bounces off the mirror and then comes back here, we can work out what direction it's going by taking a third pin and lining it up with the, oops, no good if I've moved it. Fortunately I drew around my mirror so I can replace it in the same place. So there, I've placed now a third pin in the way of the reflection. And so if we look down from above again, the light must be going from here, the object pin, striking the mirror, bouncing off and going through that point, because I obscured the reflection with my third pin. But I still can't work out exactly where it hits the mirror here, because we know the law of reflection. We could infer that it's in between those two pins exactly. But what I'm now going to do is I'm going to take still a further pin and line it up with the reflection of the pin in the mirror and this pin as well, so we can then join a straight line between this pin, that pin, and the point where it must be coming from the mirror. So again, I'm going to pop the phone down. As before, we wanted to line up the reflection in the mirror and the third pin. Now I take my fourth pin, move it across my field of vision, or the field of vision of my camera in this case, and I line that one up as well. So there's 3 pins, hopefully roughly all in a row, all lined up with one another. Maybe not perfectly, but hopefully it'll do. So the situation from above looks like this. I've got light coming from here to the mirror, to this pin, to this pin. And I can now remove my mirror and trace the path of these rays of light. So I can work out where it must have bounced off the mirror by doing a straight line between these 2 pins and to the mirror. I'm actually going to go slightly inside the surface of the mirror, because if you look at the mirror side on, the silvered surface is actually inside a glass covering, and that's where the light actually bounces off. So it will bounce off the surface about 5mm inside there. And that's where it bounced off the mirror, and it came initially from the object, which is over here. So I'm just going to join those two over there. So what we're saying is the light came from the object, bounced off the mirror, and went in that direction, obeying the law of reflection, we hope. So if I drew a normal line in here, the angle of incidence would equal the angle of reflection. All that tells us, though, is that when we were looking from over here, which is where we placed the camera, the image in the mirror looked like it came from somewhere over there, sort of from inside the mirror. So we need to carry on this ray that we drew going towards the mirror with a dotted line, just carrying on in that direction. So we don't know where exactly it was. It looked like it was coming from, it was somewhere down that line. If we want to work out exactly where the image appeared to come from, we have to now do the same experiment but from a different angle. So we'll look at the same object, but we'll now line up two more pins from a slightly steeper angle and see what happens. So again, I'll stick another pin in which gets in the way of the reflection, but from an angle which is slightly shallower, or steeper, sorry. So once again, we've got the camera down here. Now obviously now we're missing the mirror. I'm going to put it back exactly where I placed it in the first place. And we're once again looking at the pin in the mirror. This here is the object pin. And I'm going to place another pin at this different angle in the way of that reflection. So there it goes. Actually, I'm not happy with that angle. That angle is too close to the other one, so I'm going to shift it a bit. We'll move it quite a lot straighter. There we go. So this pin obscures the reflection of the other pin into the in the thing. And just like before, I'm then going to take a third pin and obscure both of the other pins so we can work out the straight line path that the light was travelling. So I'm going to move that one across until it gets in the way of the first one and the second one. It's not so great with the focus there, but you can see they just all line up just about. So from above, this looks like this. The light coming from this object that we're looking at in the mirror bounces off the mirror here and goes through these 2 points if we're looking at that angle. But if it bounces off the mirror at a slightly different angle, it bounces off and goes through these 2 points. I can do exactly the same thing as before and join the path between these 2 points here to say that the ray of light must come from the mirror and out to these points from that position there. Again, bouncing off a point just inside the mirror because that's where the thickness of the glass lies. And this must have gone to the object about there. And just as before, I can carry on the ray coming from these other two pins. And where that ray meets the first ray should be the point where the object appears to be inside the mirror. So I carry it on like so. And this point here, where these two rays meet, is the image position. Now you can see I've got the angle slightly wrong. It appears to be behind the mirror, and the distance it appears to be behind the mirror in centimeters is about 3 centimeters, whereas the object is in front of the mirror just over 3 centimeters. So I'm wrong by a millimeter or so. But essentially, we take all the pins out. Drawing those two different rays, paths of light enables us to work out where it is in the mirror that the object appears to come from. It's not really there, it's a virtual image, because clearly that's where the object actually is, but it appears to us when we're looking in the mirror to be somewhere around here. And if we got the angles exactly right, the distance it was behind the mirror, there, distance 1 would be exactly the same distance as the object is in front of the mirror, distance 2. So the two things would be equal. One thing you can realise is that if you looked directly into the mirror, so we looked at it from an angle of 90 degrees, the pin that we're looking at in the mirror can be obscured by itself, i.e. the light will bounce off at 90 degrees. So we could just draw a line at 90 degrees to the mirror, straight into the mirror, and see where that joins either of the other two rays, just as a double check. So I just do that here. Ooh. Trying to get into focus there. There we go. So I'll move it closer now. So I could draw a ray going straight through here, perpendicular to the mirror, and that could be one of my rays as well. So where this point meets the other two would also be the apparent position of the image inside the mirror. So the basic rules to remember are that images formed in plane mirrors are virtual. They're not real because it's not really there. It just appears to be there when we look in the mirror at the stuff. So when you look at things in the mirror, they appear to be inside the mirror, like so. I'm not really inside the mirror. I'm up here behind the camera. Yes, they are the same distance behind the mirror as the object is in front. Another thing we can determine about objects in mirrors or images in mirrors are that if you look at the reflection in a mirror of something like some words, there we go, they don't make much sense because they've been switched from left to right, so they've been laterally inverted. We need to talk about why that happens with another video, I think. But anyway, that little experiment is how you produce a ray diagram to prove that the image inside in a plane mirror appears the same distance behind the mirror as the object does in front. So you need a ray diagram looking something like that. Okay.